Calculator with you?
Yeah.
What kind is it?
84.
Okay, great. Everybody except you guys has a 84 today, so. So we're just going to get these two programs in there and make sure they all work. So let's start with the compliance matrix.
Oh, the screen isn't on.
Did I do that last time too? Yeah, you've done it a couple times.
No, this is just the second.
Oh my God, I just called Joe John in class today like a freaking idiot.
So for the rotation matrix, would you say like it should just spit out a matrix, or do you like?
Yes, but
So you just multiply by the function then?
Yeah, but in the 84, it's going to be a little different. So okay, here's how you're going to do it in the 84. So go to the go to program. Can I use someone's? Do I have one? Can I use it for just a second? I think I can move that quick. I just want to. Okay, and then go to new. And then, I don't know, I guess I have usually called this CMPL for compliance, but you can call it whatever you want. And now, okay, so we have to, okay, well, the first two things are easy. So go to program, once you're in that new environment, go to IO and go to prompt. And then you'll make it say, prompt E. And then do the same thing, and we'll put it in for V. That'll represent the Poisson's ratio.
I'm getting a syntax error. Oh, there's an extra E right there. What do you name? That's divided by A, right? Well, it looks like, yeah, so it's ENU, but you have NUE divided by E. So like anytime you have any amount of letters together, it's gonna read them as like a variable.
And
Yeah.
now, I guess, just to speed this up a little. Now we don't have to do that. Okay, so now this maybe is a little out of order, but let's get out of this programming environment and define a matrix that we're going to use. Okay, so go to matrix. So go to second matrix.
I'm still getting a syntax error.
And go to edit.
I mean, that's.
And decide which one of these matrices you want to put the compliance matrix in. I don't know, maybe you might have some that you save for something else, but find one that isn't interfering with the other stuff you do. I guess you have a bunch of 2x1s. Can I just put it in C?
Yeah.
I'll put it in C for compliance. It's easy to remember.
Oh, okay. So your parameter
And once you're in there, it'll say, you know, you want it to say matrix C, and you want it to say 6 by 6.
Cool. Okay, thank you. So, yeah, and then I would just test it out. Yeah.
And make sure that everything is zeros in there. So set all the elements to 0.
I'm having trouble. All your functions. In the parameter of the
Which
Right.
that's the most annoying thing about TI calculators is change. Every version is so different. Okay, this is the part that just is absurd about this TI-84 thing. So there's a very nice, simple syntax for entering matrix elements in the TI-84, but it won't let you just type it. You have to go to the actual matrix to get it. So here's what I mean. So once you're here and you have that matrix defined, go back into the program, go to Edit, Compliance, and you're back in there. And we're going to say 1 over, so go 1 over E, and you're going to use the store button towards the bottom. Store. And now you have to go second matrix and go down to C or wherever you put that empty matrix and click on it. And it'll in your program, it'll put this. Okay? You're like, why can't I skip those 5 extra clicks and just type in bracket C bracket? No, it won't accept that. It won't recognize it. But now go 1, 1. So that's the matrix element. And that you can type. The 1, 1 you can type. And then we'll go negative V over E. V. This is great video. This is going to be this is the one that's going to rocket me to
YouTube fame.
Yeah. To Logan and whatever Paul level YouTube fame. Jake Paul.
I don't think you want exactly that kind of fame.
Yeah, slightly different maybe. So now you have this, and again, you're going to do the same thing. You have to go to matrix to have it enter this C, and then you're going to enter 1, 2. Okay. You can have this back now and start. And let's see, how many times are we going to do this? 9, 10, 11, 12. We have 12 entries we have to make. So negative V over E, go to the matrix environment, click on C, 1, 3. And now we're done with the first row because we already set everything to zeros. And now the second row, now you'll go negative V over E, and put that in 2, 1. 1 over E, put that in 2, 2. Is everyone finding that store command at the bottom? Yeah. And then negative V over E into C 2, 3. And now the third row, negative V over E into C 3, 1. Negative V over E into C 3, 2. And positive 1 over E C 3, 3. And now we're on the shear stress rows and shear strain rows. So 2 times 1 plus nu over E, put that in C 4, 4. 2 times 1 plus V over E, put that in C 5, 5. And 2 times 1 plus V divided by E, put that in C 6, 6. And so now, once you have all this in and all the syntax taken care of and whatever, whenever you call this program and enter a new value of E and V, it will replace what's in that matrix. I have it for the matrix C. It'll replace what's in that matrix C with the new values. So let's, when you get that done, let's just all enter this test case so we all are sure we're getting the same thing. Let's enter in, the one we're going to use more than all the other ones combined is for steel. Yeah. Yeah. So call it with E equal to 200 times 10 to the 9, V equal to 0.3, and it should give you a matrix. Oh, I don't have it on my calculator because it ran out of batteries. Can a couple people do that, and if you get the same things, we'll trust it. It should be
5e minus 12
okay. So 5e minus 12.
down the top diagonal,
Let's just go across the rows.
and then minus 1.5 times 10 to the 12.
Okay, and so now I can fill out the rest of these. So, and these are minus 12.
Yeah.
I'm going to give you a quiz question sometime that's like, do you consider steel compliant? Would you say it's compliant?
No.
Yes, the answer is no, correct. That's what you should feel about it. I'm not trying to tell you how to feel, but
Depends on the temperature. That's true.
That's true.
Hey, don't forget about rust now.
Oh, I thought you were going to say, and pressure. Oh, and then what do you get for the value of in the shear spots?
1.3 times 10 to the minus 11.
So what do we do on the 84s? Because I got a single number output.
Yeah, that number output doesn't matter.
Okay, so then I go.
So now go to matrix, and all those values should be there. But then if you click on that matrix, then you can just hit the times button and multiply it.
Yeah, I see it now. Okay.
So it's a little like click, 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 which is a little annoying, but it's not too bad. Okay, so everyone just check and make sure that if you enter in these values of E and V, you get these, how to do that. So now let's say that you have, so now with that compliance matrix, let's multiply it by, so to get the Voigt strain, let's take that matrix and multiply it by, I'm just making up numbers, 1 times 10 to the 6, negative 2 times 10 to the 6, 0, 4 times 10 to the 6, negative 1 times 10 to the 6, 0. And you're just going to use the regular multiplication button. You just have to enter this in. There are a few different ways to do it for the different calculators. For an 84, you could do it as 1 times 10 to the 6, negative 2 times 10 to the 6, 0, 4 times 10 to the 6, negative 1 times 10 to the 6, 0. For an 89, it's a little quicker to use semicolons instead of the doubled brackets. So you do 1 times 10 to the 6, semicolon, negative 2 times 10 to the 6, semicolon, 0, semicolon, 4e6, semicolon, negative 1e6, semicolon, 0. And when you guys get it, will you read those off to me? What you get?
8e to the negative 6.
8e to the negative 6.
Negative 1.15 to the negative 5th, e to the negative 5th.
Okay. Negative 1.15 e to the minus 5.
Yep. 1.5 e to the minus 6.
Okay.
5.2 e to the negative 5. Negative 1.3 e to the negative 5. And 0.
Okay. And by the way, just as you sort of are getting used to these relationships, notice that a 0 in a normal stress doesn't necessarily mean a 0 in the normal strain, but a 0 in a shear stress always means a 0 in a shear strain. Did other people get that?
I got roughly.
Okay, within round off error. Yep. Yeah. So here is the rotation matrix. So remember, what we're doing here is rotating the coordinate system about the x-axis. And so you're going to do all the same stuff as this. All the people with 84s are going to do the same stuff as this. So you're going to go program, new, and call it rot x. And now that you're in there, go hit program again. Go to, I guess it's input output. I didn't write that before, but go to input output, prompt, and all you need to get here is an angle. So I think it might let you use the variable theta. And I'll help you with that 89 in a second. It's a little different again. But if you can put in a theta, sure, use that. Otherwise, put in A for angle or whatever. It doesn't matter. And so what that's going to give is, you know, it'll say prompt for that angle. And then you're going to need to have a matrix prepared for this one that you're going to want to set to 0. You just need it to be the right size. So go again to some matrix that you're not going to use for other stuff and go. You can use it actually for all of the rotation commands, just it has to stay 3 by 3 or this program will crash. But go to second, matrix, edit, put it in D or whatever. And then you want to make that matrix D 3 by 3 this time. And set the values to 0. No, you don't have to do that this time. We're going to adjust all the values. And now you can go back into program, edit. If maybe you're already in there, I can't remember. Maybe you're still in there. But now what you want to do is go to like nope. Go put 1 into the value D 1, 1. And remember, you have to go get that bracket D. You can't type in bracket D or it'll crash. Then go to 0 and go get that D from the matrix thing and put that in 1, 2. 0. Put it in 1, 3. Then for the second row, go 0, 2, 1. And now we'll go cosine of the angle. Put that in 2, 2. Sine of the angle. Put that in 2, 3. Then 0. Put that in 3, 1. Negative sine of the angle. Put that in 3, 2. and positive cosine of the angle. Put that in 3, 3. Okay. And last, like on Monday, I gave you what the matrices looked like for the rotation about y and rotation about z. So see if you can do, a function, a program wrote y and a function wrote z based on the element values I gave you on Monday. If you can't, we'll spend some time still on Friday. We just have to make sure everybody has this working, okay? Because in the old